Okay, here we go. Okay, here we go. Sine, cosine, tangent. Hopefully you know SOHCAHTOA. Because if you do, then you'll survive next year. Next year in pre-calc, you have to know this stuff really well. That's why we're reviewing it now. Sine is opposite over hypotenuse. Ta, C-A-H, stands for cosine, means adjacent over hypotenuse. And tangent, TOA, opposite over adjacent. All right, so let's see how that sets up in some typical problems. I know, I'm hungry too, and I don't know why those are on there. But well, it says the name right on that thing. Woo! It just deleted the whole thing. Oh, I hit the wrong thing. All right, sorry about that. Here we go. I would like you to look at this problem from the 50 degrees perspective. From the 50 degrees perspective, this is the side right next to it. So that's called what? Adjacent. So I'd put a little A, and then if this was a worksheet, and then this one I would say is like the opposite. Then I could write the little formula that goes with this picture. This is the most important thing, is to being able to see where each thing goes. All right, so I need to pick either sine, cosine, or tangent. And I agree, tangent is a good choice because we have opposite and adjacent. So I start with tan. Technically, it's a lowercase tangent, which doesn't really matter much, but it's supposed to be a lowercase t. All right, and then next is a degree, and it could be in degrees or radians. You don't even know what a radian is yet, but it's basically a way of measuring angles that doesn't use degrees. And a radian is about 60 degrees or so. But anyway, tangent of theta, and theta is the degrees, equals like opposite over adjacent. I'm just writing out the general form for tangent. That's what tangent always is. Tangent of some angle, that's a variable called theta, equals O for opposite over A for adjacent. Then I could actually replace all of these things with something. Do I know my angle? I put in 50. Do I know my opposite side? No, but I put something there. Why? Because it says a letter Y right there. And the last thing is the adjacent side. Do I know that? Yes, just put an 8. Don't use the units. It'll just mess you up. Just make sure that you know your answer will be in centimeters because the other part was in centimeters. Now this, tangent of 50, I don't expect you to be able to do in your head. You'd grab a calculator for it and type it in. And the weird thing is that probably one of you or two of you in this room will get the wrong answer and you won't even know it. Your answer will be different than everybody else's. Can anybody guess why that could happen? Where two people could type in tangent 50 equals, and some people get the right answer and some people the wrong. I think you were first. Something about the mode, yes. Be more specific. Yes, it could be in radian, not degree mode. So if your calculator's in degree mode, you'll get the right answer. Tangent of 50 should be positive. If it comes out negative, you're going to be in radian mode. You want degrees. You know why? Because it says a little degree sign right there. It wouldn't say a little degree sign if you were supposed to be doing it in radians. So did you get the answer? 1.19. Would you? How many of you guys had the same thing? 1.19. I'm curious. Did any of you look and found out your calculator was in the wrong mode? Ah, look at that, like 8 or 9 people. So that happens a lot. So watch for that on the SAT tests. Like the biggest test, or ACT, the biggest test you'll probably ever take, unless you end up going to law school, in which case your LSAT will be the biggest test you ever take. But the biggest test you ever take as far as like really being important in your high school career is probably the SAT or ACT test. And you don't want to go through that whole test through the calculator in the wrong mode. Like if you're a random group of people, which you pretty much are, it was like 7 people that had it in the wrong mode. And you wouldn't even know it, and you get these wrong answers. It really sucks. Okay, so 1.19 equals y over 8. That looks like an equation to me. Times by 8 on both sides, and you get 9 point. You know why you're getting different answers there? Because some people have it rounded to 1.19, and some people have the actual answer in there. I'm going to say around 9.5. That way it's close to that. If you're close to that, you probably just has a rounding difference error. In other words, this is not really 1.19. It's actually goes a little farther than that. Okay, so the answer is about 9.5. So I'll go back up here and I say 9.5. And I ask myself, does that seem reasonable? Well, actually, from the picture, the drawing doesn't look like that. But don't ever trust the drawing to be drawn to scale. Okay, so just because this side looks longer up here doesn't mean that it's going to be longer. Here's a way you can logically reason it out. Would you agree this has to be 40 degrees? And would you agree that across from the bigger angle should be the bigger side?
Yeah.
You see how 40 goes with 8 and 50 goes with 9.5? Doesn't that make sense?
Yeah.
All right, so you sort of have gut checked your answer to make sure that it makes some sense. Then I'd be confident to say 9.5, and then I got to remember it's in chickens, right? Or centimeters, yes. Okay, let's try another one. Without me giving you any help, try that one with the Twixt bar next to it. Is that like dark chocolate on there or something? The limited edition? I don't know. Makes me hungry, though, I can tell you that. So why aren't we using tangent? Because we have the adjacent and we have the hypotenuse. What has adjacent and hypotenuse in it? Ka. So it's cosine of 31 equals, and I like to put these little helper things in there. Cosine is ka, adjacent over hypotenuse. And sorry about the pop up there. Ever since they wiped the computers, it reset all of the settings back to the way they were before the computers were, we had them all tweaked to be just perfect. So yeah, I don't know if you saw it. Did you hear about it in other classes later on Friday? A lot of people's computers just went to shutdown and restart mode, and it not only reset the computers, it totally wiped all the computers and then reloaded the whole operating system onto them. So yeah, it's kind of like being hacked, except I think that the main office help desk people somehow pushed the wrong button and it just did it by accident. It doesn't actually hurt it. It gives it the new update, but all your settings you had on there before, like not allowing those pop-ups and stuff, all got wiped and got to redo them all. Okay, so adjacent is the 13. Hypotenuse is the x. Hopefully that's how you set it up. Then you actually figure out cosine of 31. You type it in your calculator. It gives you a decimal. Then here's the thing. Some people don't know how to solve it from there. Not really. To start with, what is cosine 31? Okay, I'm rounding here, so your answer might be slightly different than that. And then you multiply by x on both sides. And then you divide by 0.86 on both sides. Oops. And then the answer is 13 divided by 0.86 is? So x equals 15.2 approximately. I'm rounding again. And if it's about 15.2, I look at this and make sure it makes some sense. This is bigger than this is. Does that make sense? Yeah, it's the hypotenuse. It should be bigger. All right? All right. If it depends on the rounding, depends on what you rounded to. Okay? It depends on what you round to. If you don't round at all, maybe it does come out to 15.1 something. What I'm saying is earlier in the problem, are you listening to me? I don't think you are, so I'm not going to talk to you anymore. Okay. This one. Solve it quick. All I want you to do, in fact, is just set it up. Are you using so, ka, or toa? So. Sine is opposite over hypotenuse. So sine 28 equals opposite over hypotenuse. All right, there's another kind of thing that we got to go through. Those are a whole bunch of the review of those things. These triangles are huge. Everybody copy these down. We got to get these done before you go to lunch. These are the 45, 45, 90 and the 30, 60, 90 triangles. I know you learned them back in geometry and you probably thought, one and done. I use this for one day and I'm done with it. No, it's one that you're going to need all next year. Whether you're in pre-calc or PCAT, they use these triangles a ton because these are the ones that you can do without a calculator. See, you can do sine of 45 without a calculator if you know these triangles. Okay, and a lot of your tests don't have calculators allowed, and so these triangles come up a ton. We'll talk more about these after lunch. So we're back from lunch, and we were talking about these triangles. They are really important because they help you figure out trig without a calculator. All right, so this triangle on the left here also could be, instead of 1, 1 and the square root of 2, the sides could be 2 and 2. And then, no, do you know what I just did to both of those? I doubled them, so therefore 2 square roots of 2. Get that? 2 times each of them. If I multiply everything by 2, okay, if I go over to this other one over here and I say I want it to be, this 2, I want it to be a 4. Well, that's okay, but then this 1 has to become a 2, and this root 3 has to become 2 root 3. See how I just doubled everything? All right, so in pre-calc we get much deeper into those. All right, next. If you're going to set this up in terms of legs and a hypotenuse, you could think of the leg as 1/2 of the hypotenuse times the square root of 2. Now, I don't know if that's going to help you, but the way I like to do these is to always just look at the triangle and see, oh, it's a 45, 45. So I know that this has got to be this kind of triangle. And then I set up a proportion. All right, so would you please write this problem down on your paper right now. And I'll show you how you'd set it up. Sketch the little triangle. Sketch the other little triangle. Because if we remember that it's 1, 1 and square root of 2, then you can set up a proportion and say, you have to use your number that's a real number and not the variable. 6 is to 1 as, no, it doesn't go, you have to say the same direction, as x is to 1. And now you can see that x would have to be 6. Now I get, you can probably just look at that and say, well, if this side is 6, that side's got to be 6. Okay, yes, that's true. But it gets harder because some of these, they just don't work out quite that nice. Let's set up one of those same proportions except for y. Start with the 6, and this time make sure y is in your answer. So it's still 6 is to what? 1 as y is to, good. Remember doing these in geometry? Similar triangles? This is to that as that is to that. Okay, and I set up a proportion, and that way I can just cross multiply to solve it. And so 6 root 2, this times this, makes 6 times root 2, and y times 1 is y, so y equals 6 times root 2. So there's my answer. Now some of you guys are just going to look at this and say, oh, well, duh, instead of a 1 for a side, it's got a 6. So that means it's how many times bigger? It's 6 times bigger. So I just can say that this is 6 times bigger than normal. 6 times bigger than what's normal? Square root of 2. The normal one was 1, 1, and the square root of 2. So it's 6 root 2. Now some of you, that's going to come natural, and other of you are going to be like, what did you just say? I don't get that at all. And that's okay. All you have to do is set up proportions like we just did here. All right? Set up the proportion, please, for that one. Don't have to draw the picture, just set me the proportion. This over this equals that over that. So M&M, would you tell me this one? X is to 1 as 12 is to square root of 2. That works. I would have started with the 12, but this will work. Good job. Let's set up a proportion just like that for y. So you could, I'm going to start with 12 this time, just because I like starting with 12. 12 over root 2. I like to start with the ones that are normal numbers, and then get into the variables later. equals, if this is to this, I got to stay the same direction. That is to that. Okay? Cross multiply to solve. All right, this one's similar, but it's not a right triangle anymore. So we got to fix it and say, well, what would this be if I was going to make it a right triangle? Well, how long would this be right here? That would be 1, right? And how long would this be right here? Square root of 3. Because why? Because a squared plus b squared has to equal c squared. And this side right here is 1 squared plus I don't know what squared has to equal 2 squared. And so then I can say 1 plus I don't know what squared has to equal 4. So this has to be the square root of 3. I'm going to call it a squared. Subtract 1 from both sides. All right. And other way you could have remembered it is this. Look it. It's a 30, 60, 90 triangle. So there has to be 1, 2, and the square root of 3 are the 3 sides on that thing. Okay. I think that's good enough. This one you'd set up the same exact way. Say this over this equals that over that. Same kind of deal. Questions on those? All right, that's what you got for homework for today. It's a review of one of the important things in geometry that you have learned.